So the three areas that I'll talk about that are in the report are transportation, public safety and security, and meeting the needs of low-resource communities. And we chose those three areas here to highlight because they have short to long-term time to impact. And as I talk about these areas and cover topics within these areas, you'll see a particular pipeline of in the systems that I'll describe. They start with some type of input data. That input data is used to build a predictive model to make predictions about the surroundings. And those predictive models are then used to build decision models to make decisions, interventions. In some cases, we only start from the data and end up with the predictive models making predictions. In some cases, the entire pipeline is complete. The first topic I will talk about is transportation, driverless cars. This has already been mentioned here. And this clearly will be the first domain where public will be asked to trust AI on a large scale. The problem for driverless cars, everybody knows, sensing the surroundings, car state, and then taking actions like changing lanes and parking and so forth. And the AI technologies that are used are computer vision and machine learning and so on. There's certainly been surprising progress in academia and industry. We all know about autonomous vehicles from Google, Tesla, and so forth. And not just cars, but drones. So where we are now is the technology has made rapid progress, but we must grapple with a world full of people, which includes other pedestrians, other drivers, and so forth. Nonetheless, the report reports that in 15 years, we expect autonomous pickup and delivery of people and packages to be reached. Let me now turn to public safety and security. And remember that pipeline of data to predictive models to decision models. This entire pipeline is employed in fraud detection. This is a AI technology that's been in use for many years, if not decades. And in this process, I wanted to say the report looks back 15 years as well as ahead 15 years. And fraud detection is one of the looking back in terms of successes of AI. And the basic problem is how do we tell which transactions are fraudulent in terms of credit card transactions and so forth. The AI technology that gets used is classification via machine learning. So you have data on records of fraudulent and legitimate transactions, and we build predictive models to detect which transactions are fraudulent and then autonomously decide to terminate transactions that are fraudulent. Now, here there isn't as much of an interaction with people. When we come to the next technology here, which is predictive policing, here we are stopping only at prediction. We aren't completing the pipeline, as I said, towards intervention. We are trying to predict here crimes in terms of crime locations, times at which there are higher risks of crime. Here we are again building predictive models via machine learning. So we take as input lots of crime data, past crime data, to build predictive models about the probability of high crime areas or locations or times and so forth. This is getting adopted by different police departments. The report expects this to spread to many different law enforcement agencies in the future. The report also discusses some of the challenges that have been brought up in terms of ethical issues and so forth. Now here, clearly, we have stopped at prediction. The next step then is to go beyond prediction to intervention. And here I'm talking about protecting our urban infrastructure, whether it's airports, trains, ports, from intelligent adversaries who can monitor our defenses and exploit any patterns. The challenge for security agencies is that they have limited security resources. And so they can't be everywhere all the time. So how do you schedule and plan and allocate these limited resources? The AI technology that's been in use here is a computational game theory. The way we do this, by we here, throughout this talk, I mean the entire AI community of report writers. We take data from domain experts, past crime data, to build decision models, which are these games. And solving massive scale games then provides recommendations, intelligently randomized inspections and patrols to ensure unpredictability and net coverage of important targets. This technology is in use, adopted by the US Coast Guard for generating patrols in different ports, by the Federal Air Marshal Service for assigning air marshals to flights, by different other security agencies, and the report expects this to be in much more widespread use in the future. Finally, turning to meeting the needs of low-resource communities, I will again report one topic where we stop at the predictive model stage and another where we complete this entire pipeline. Starting with the first here, which is for prediction, we're trying to use machine learning for preventive lead poisoning in children. So lead can be found in many homes in paint, and so the question then becomes which houses to inspect for lead. Again, by using 20 years of data on children's blood tests and house inspections, we can build predictive models so that pre-birth predictions can be made about which houses need lead inspections when a pregnant woman visits for a regular health check. Along the same lines then, but now going towards prediction and intervention in low-resource communities, we can think about social networks that can be used for raising HIV awareness among homeless youth. Homeless youth are 10 times more likely to have HIV. The infection rates are higher than the general population. Yet they distrust authority, and therefore peer intervention is assumed to provide a much better way of spreading HIV information. So we can use a social network of homeless youth and select key peer leaders to spread information. The challenge, though, is that the networks tend to be uncertain and dynamic. So by the AI technology that can be used here is using influence maximization to figure out who would be the right peer leaders to select to spread the information. But the way it works is you take network data and then select a first set of influential leaders, and then not only have them spread information, but gather information about the network from them. This then allows us to select next set of peer leaders in a better way. So this decision aid based on this technology has already been, has seen a pilot done in Los Angeles showing an increase in HIV testing. So here I've covered the three topics that Barbara mentioned: transportation, public safety and security, and meeting the needs of low-resource communities. The report has a lot of different coverage of different areas, and I'm personally very excited to see all the positive impact of AI, all the different ways in which the report identifies that AI is being used for social good today and the potential for that in the future. Thank you.